In this presentation, I'm going to go through how to complete the compact term and reversion model that is part of the series of self-correcting exercises under partial interests. Let's look now at this particular model. This exercise is a fairly advanced exercise and brings together a number of the tools and techniques that we've learnt in other sections. I'll work through it cell by cell to illustrate how the solution works. We'll begin with cell C23, which is the weekly profit rent in the first year. What's required here is simply the difference between the weekly market rent, which is what the owner could get if they were able to lease the property today on the open market. And the difference between that and the weekly passing rent. So it's simply the difference between cells C13 and C14. The next two cells, C24 and 25, are merely the computation of the effective weekly discount rates. What this is going to do is take the annual discount rates, which are found in cells C18 and 19, and convert them from an annual figure to their effective weekly amount. Now, this is not merely the division by 52 or 52.2 to be more precise. It actually uses the equation which is given to you to the right of in row 24. I'll demonstrate what that equation looks like. Note in this equation that I have made F13 absolute by using the F4 function key in the Windows environment. This enables me to fill this equation down into C25 without having to go through the trouble of writing it out again. Now we move down to cell C26, where we work out the present value of the first year of market rent to the tenant. In this we use the PV function, the tenant's effective weekly discount rate, and the market rent. There are a number of important things to note in the use of the PV function in this case. The first one you'll notice is right at the very right hand side of the function, where we finish with 2 commas and the number 1. This is because we want to specify that the rents are paid in advance, or in finance terms it is an annuity due, and so we have to specify using the flag 1 at the end of the PV function. You can read more about this in the help on the PV function within Excel itself. The second thing that you'll notice is that I've gone to the trouble of absoluting both the rate and the number of periods. And this simply makes it easier because I'm going to be filling down parts of this equation for the next couple of cells. The next cell, C27, is very similar to C26 in that now we're looking for the PV of the first year of passing rent to the tenant. And I can actually fill down the equation from above because I've structured it using the absolute addressing, as I've mentioned earlier. C28 requires a little bit more adjustment to the equation. In this case, I'm using the landlord's effective weekly discount rate as the rate in the equation, and I'm also using the passing rent. C29 requires the tenant's compound discount rate. This is the tenant's discount rate compounded with the property growth, which is a very useful rate because it enables us to do these models very compactly. The general relationship that we use is shown to the right in row 29. A close look at the equation reveals that I've also used an absolute in this equation, again so that I can simply fill it down into cell C30, where I calculate the landlord's compound discount rate. Using the absolutes is not necessary It's simply a way of saving a little bit of time in transcribing the equations. If you use the absolutes, you'll be able to also fill down. Otherwise, I'll leave it to you to insert the equation for cell C30.
We're now in a position to compute the present value of the tenant's interest over the term of the lease. This is made a little bit more complex because of the growth in the market rent, while the passing rent is remaining stable. And that means we can't simply run a PV of the profit rent, because the profit rent is changing in a way which is a bit difficult to simply model. The easiest way, oddly enough, is to do two present value calculations, one for the market rent and subtract from that the present value of the passing rent. Let's look at how that goes. Present value. Now the market rent is going to be growing, and so we need to use the tenant's compound rate, the number of periods, the payment, we put the negation in there to take the correct sign. We're going to put the two commas and the 1 in to say that it's an annuity due. And now we're going to subtract from this the present value of the passing rent. Notice that I'm using an addition there rather than a subtraction, and that's because of the sign conventions. I'll let you think through why I'm able to get away with a positive there. It saves a double negation. The discount rate that I use for the second one is the lessee's discount rate without compounding, same number of periods. The payment now relates to the passing rents PV, that's the annual PV. I do my two commas and a 1 to make it an annuity due. And there we have $45,000 is the interest to the lessee. Let's move now to the landlord's interest. This is somewhat simpler. You can look at the comment here, the suggestion, and that tells us it's simply the PV of the remaining passing rents. Let's work that. Because the passing rents are not growing, the rate is the lessor's discount rate, number of periods is the 17 years, the payment is the annual value of the passing rent to the landlord. Put a negation in there, and the two commas and the 1 to say that it's a annuity due. We now want to work out the reversionary interest. In other words, what is the value to the landlord once the lease is finished? When you start to do that, we're going to work towards a capitalisation. So to do that, we have to work out the rent at the end of the lease. We're going to do that by simply doing a simple sum of the market rents, multiply that by the number of weeks in the year. I'm going to then escalate that to the year after the last year of the lease. So I'm going to escalate that by the property growth. That's 1 plus the property growth raised to a power equal to the term of the lease plus 1, because I always capitalise on the first year after the sale. So the rent in 18 years' time is going to be $25,000. From that, I can quite easily capitalise that rent using the cap rate that we have been given in data. It gives us $281,000. However, today's value for that is somewhat less, and so I have to do a present value. I'm going to do this longhand. I'm going to take that value, I'm going to divide it by 1 plus the landlord's discount rate raised to the power of the number of years. That gives us the present value of $40,000, somewhat less than the $281 that we started with. The landlord's total interest can now be computed as simply the reversionary interest plus the term interest of, in this case, $84,000. Just to complete the calculation, not totally necessary, we'll work out what the current capitalized value is. And we do this by taking the current annual rent, the market rent in this case. We're going to divide that by the cap rate. That gives us $165,000. What we see here is there is an approximate correlation between the tenant's interest added to the landlord's total interest. Comes fairly close to the $165,000. Now, in this model, there are a couple of reasons, apart from what we've introduced as the marriage value, that makes this different. And one of the reasons is here we're using capitalization, which kind of implicitly assumes an annuity due, combined with complex discounting arrangements which are all based on annuities due, and so doesn't quite add up as nicely as it could. However, that's the model. It's a very powerful and flexible model. If you've done it according to the way it's run here, all you need to do is change the data and you'll be able to use that for a number of very useful purposes in practice.
So there you have it. This is probably one of the most complex models that you're likely to find in property practice. And so by getting through it, you really got to the point where you've mastered really the hardest calculations that you're likely to find. I'd like you to spend some time to make sure that you understand each part of this model, because these various little components, bringing effective rates, weekly to annual, the compound discount rates, and those other parts are really important to understand, because they give you a toolbox that you'll be able to use in your own professional practice to be able to build models to solve particular problems. And as long as you know the components and how they fit together, and how to think through turning a property puzzle into a model like this, this will mean that you'll then be able to apply this to your own property analysis into the future. By the way, we're using these models specifically for commercial urban properties, but there is nothing to stop these being applied in all other markets as well. And one of the things which is particularly interesting is the way that they are being used more and more in the rural environment as well. And so really no one gets out of the need for these models in actual practice.